What are square roots and what are radical expressions? In this lesson, we'll seek to understand both of these two concepts. Let's begin with square roots. The number c is a square root of a if c squared equals a. That's our definition of square root, but let's try to understand what that means. Find the square roots of each number. So let's look at the number 81. What is the square root or the square roots of 81? Well, to understand this, we have to think what number multiplied by itself, what number squared gives us 81. And we know that that number is 9. So 9 is the square root of 81. But actually, there's another one. Because negative 9, when it's squared, when it's multiplied by itself, also gives us the number positive 81. So there's actually two square roots for the number 81. Similarly, for number 100, you have 10, which is 10 times 10, and also negative 10. This means that for every number that's a perfect square, like 81, 25, 64, these numbers have two square roots, the positive and a negative integer. Now, sometimes we don't want to refer to both the positive and the negative square roots. We only want to talk about the positive ones. So the non-negative square root of a number is called the principal square root. So the principal square roots, for our last two examples, the principal two square roots would have been 9 and 10. Now let's connect it to the word radical. What does radical mean? Well, the word radical expression comes from the radical sign. So the radical sign, this symbol right here, indicates the principal square root of the number underneath the sign called the radicand. So let's understand what these vocabulary means in relation to one another. And our examples below, this means we want to find the principal square root of the number 64. Here, the number 64 is what we would call our radicand. That's our vocabulary for the day, radicand. And the symbol that it's under, this symbol right here, is called a radical sign. And so what it really wants to know is, what is the principal square root of 64? And we know that number is 8. It's not asking us what the negative square root is, because of our radical sign, it only wants to know the principal square root. For our other example, number 225, my radicand is 225, and it's underneath my radical sign. So it wants to know what is the principal square root of 225. And that number is 15, because 15 times 15 equals 225. Now, in this unit, we're talking about radical expressions. So a radical expression is an algebraic expression that contains at least one radical sign. So we can look at these four examples here. Square root of 14, the square root of x squared minus 5 over 2, 8 plus the square root of 2x, the square root of t squared plus 4. Each one of these would be considered a radical expression because they all contain at least one radical sign at some point in the expression. Now let's do some basic simplification of radical expressions. So we have 6 different examples. We'll simplify all of these. The square root of 5 squared. So if we would do our order of operations, 5 squared is 25. And now we want to find the principal square root of that. So we get 5. In the example on the top right, we again do order of operations. Negative 5 squared is positive 25, which equals 5 again. And our next example, order of operations, negative 7 squared is positive 49. Square root of 49 is positive 7. And so what we've seen so far is that every single one of our expressions ends up being positive. And that's because when we use our radical sign, we have to have non-negative square roots only. So what does that mean for our next example? The square root of 8x squared. Well, in this example, if we do our order of operations, we go square root of 64x squared. And if we found the square root of 64 and the square root of x squared, that would end up giving us 8x. But since we know that this has to be positive, we need to make sure that we indicate that this is going to be positive. So we give it the absolute value sign. And the reason we need that absolute value sign is because there is a variable. And we don't know if this is positive or negative. So we need to make sure that the expression stays positive, so we use the absolute value symbol. Let's do our final two expressions. The square root of a squared b squared. This would simply be ab. But again, since these are variables, we need to make sure that we indicate that this is a positive expression. So we'll use absolute value symbols for it. And for our last one, the square root of 9b squared, that would be the square root of 81b squared, which would give us 9b. And again, we need to indicate that that's a positive expression, that it's not going to be negative, so we use absolute values. So if we're using an expression that involves variables, we often have to use an absolute value symbol to express it as a positive, unless we assume that all of our variables are positive integers.